Welcome, everyone. My name is Namrata, and I am the Director of Communications and Member Relations at the Green Software Foundation. I'm so excited for this hour. For those of you who are joining a GSF event for the first time, thank you for being here. The GSF is a consortium of organizations across industries working collaboratively to build a trusted ecosystem of people, standards, and tooling, and best practices for green software. Green software is software that is carbon aware, hardware efficient, and energy efficient. Collectively, our members represent the software industry and its commitment to decarbonization and software sustainability. If you're interested in learning more about what we do, or you'd like your organization to become a member, visit greensoftware.foundation. Today, we're all here to delve into the intricate relationship between responsible AI and environmental sustainability. AI possesses tremendous potential to tackle some of our planet's most challenging problems, yet it also carries an environmental toll that can hurt our planet and our societies. Our mission today is to guide AI towards a greener future where sustainability and innovation go hand in hand. Before we jump in, let's preview what our expert panel will explore. There are five sort of key themes that we're going to cover today. One, the current state of green software and its future. Two, eco-friendly AI design and development principles. Three, tools to measure AI's carbon footprint. Four, the roles of policymakers, AI sustainability officers, and other actors. And lastly, how individuals and groups can drive change. Before I introduce our speakers, I want to encourage every participant to uphold our code of conduct, which means showing patience, empathy, and consideration to others. If you have any concerns, please visit our help desk, and the link is up top. Now, let's meet our panel. Moderating today's discussion is Don Nafus, anthropologist and senior research scientist at Intel Labs, who's also an expert in health, environmental sensing, and data. Joining us, we have Chris McClean, Global Lead for Digital Ethics at Avanade, Navveen Balani, Chief Technologist at the Technology Sustainability Innovation Group at Accenture, and Dr. Elif Cortez, Director of Quantum and AI at Ethiqual and Research Fellow on Tech Ethics and Governance at Stanford Law School. Let's bring them on screen. Hello, everyone. We invite everyone attending today to actively participate by asking questions, sharing your insights. We're monitoring GSF discussions, LinkedIn, Twitter, YouTube, so keep your comments and questions coming. All right, I think it's time to get started. So Don, the mic is yours.
Hello, everybody, and thank you so much for joining from around the world, it looks like. That's hugely exciting. My name's Dawn. I am going to be the panelist today, and I'm super excited to be here. I'll share that in my own work, I both am responsible. I play an active role in responsible AI governance over at Intel. I also am an active researcher in carbon aware AI. And so I personally have been really racking my head about how to bring these two worlds together. And so I'm very excited to hear from our panelists on what they have to say on the matter. With that, I thought I'd start out with our first question, which is to all our panelists here, which is that, one of the things that I think everybody probably is aware of is the recent news, particularly about generative AI, about new forms of AI where models are much larger now, and there's been a lot of news reporting about particularly, well, about many things, but the environmental footprint is the matter here. Beyond the hype, beyond what we already know from the media, help our listeners understand what else do we need to know about the environmental footprint of AI. And Elif, I'll start with you. I'll just pick on people.
Okay, thank you very much, Don. So I think for this, it's important to look at also the current research. There is a recent research by Kag and colleagues, and they aim to introduce a form of categorization to the environmental impact of AI. And many of us recognize the terms such as Scope 1, Scope 2 emissions. And in this research, they mention that regarding AI, we can look into firstly computing-related impacts, and then immediate application impacts, and then at a broader sense, we can look into system-level impacts. Regarding your question, the computing-related impacts can be divided into two: operational emissions, such as the operational energy used during computation, and embodied emissions, such as materials extraction and manufacturing associated with computing hardware. So this will be my input for this question. Thank you.
Navveen, what do you have to add to that? And you're going to have to take yourself off mute. You're going to have to try again. Bingo.
I hope this works.
Yeah.
Yeah. Hello, everyone. Very excited to be part of this panel. So generative AI, especially models like large language model, right, has a significant carbon footprint both during inference as well as training. So some of the stats are around, for instance, training a large language model takes around 500 tons of CO2 equivalent, and which is equivalent to a gasoline car, right, traveling around 2 million kilometers. Significantly also the supporting infrastructure like racks, cooling infrastructure, it also quite substantial. For instance, just for training a GPT-3 model requires around 700,000 liters of fresh water. And even a single conversation of, let's say, 20 to 50 questions consumes around 500 ml of total water footprint. And especially if all the chat prompts are used by billions of users, this is quite substantial. So along with both the operation carbon as well as the embodied carbon, especially the life cycle of hardware devices, which is another environmental concern that needs to be addressed. And basically, we have to look at this holistically to look at solving all these three problems, primarily around how can you make the whole AI process more energy efficient, not just training and inference. The second can be around hardware optimization itself, right? How do you use energy efficient hardware, chipsets, specialized chip forms. And third is making the whole process itself carbon aware, basically leveraging renewables or time or carbon intensity where and deploying your applications where the carbon intensity is low.
Fantastic. And Chris, what would you like to comment on this topic?
Yeah, I mean, both of those were great comments. I think I would just emphasize that on the hardware side, it's not just the carbon impact, the carbon footprint of the hardware, but also the extraction of materials. There's a very heavy environmental cost as well as a social and geopolitical cost. People might be familiar with Kate Crawford's book, Atlas of AI. If you haven't read it, it does a really good job kind of digging into all of these different environmental and social and geopolitical impacts. And the other thing I would mention is that if you think about the more traditional, I guess, the analytical AI that we've been accustomed to over the last decade or two, it was really kind of, I guess, easier to isolate a lot of the environmental costs because we know what teams are running it, we know how often they're doing their training and testing and things like that. But with large language models, with generative AI, especially over the last year, it has become such a easily accessible tool for so many people. There's a lot of experimentation going on right now, really across, from my perspective, across all the businesses that we work with. Everybody in the organization is now an AI developer or designer to some degree. So there's a lot of development, a lot of experimentation going on without necessarily clear value to the organization. And that experimentation can be valuable, but I don't think people necessarily realize that every time, as Navveen mentioned, every time they're running prompts, they're running queries, they're having a chat with an AI like that, there is an environmental trade-off, and most people aren't considering that cost.
Yeah. It's almost as if every interaction needs to have displayed prominently just how much water you've consumed in doing that. Okay, let's move over to the responsible AI side of the equation. So, the world of responsible AI, if I had to carve it up into two buckets, right, there's the research side where lots of folks are publishing on all sorts of techniques to, rectify things like bias, explainability, privacy issues, all the rest of it. There's also practice, right, where large companies set up a system of governance and they try to put in the internal procedures and assessments to make sure that stuff doesn't leave the door that shouldn't. And oddly, these two things have not historically been connected. And yet at the same time, companies have been making sustainability claims, thinking about how to be more sustainable for a lot longer than they've been thinking about responsible AI. So what do you think the disconnect is about? Or conversely, how do you see that the intersection changing in the next few years? And I'm not going to pick on people. So whoever has the strongest opinion on this should jump in.
I will jump in. Okay. not sure if I have the strongest opinion, but I think some of the disconnect is coming from the complexity of each topic, as high-level expertise and specialization is required in these highly important, but also very dynamic domains, such as the definition or requirements for a privacy-respecting algorithm being quite evolved in the recent years. And green algorithms are a much newer concept. And as we are seeing a commitment towards green IT for a much longer period of time, the algorithms and their operational or embodied emissions were not catching enough attention until recently. So I think this might be the reason why the teams are working on these issues more in silos. But I think this is changing now. So at least when we work with the clients explaining our vision for responsible AI, we see more and more requests from them to also include their ESG groups into the discussions with us.
Interesting.
I think to add to what Elif said, right? So in my view, I think the initial focus of responsible AI governance was primarily around, I think, ethical, privacy, and societal concerns. And primarily because these issues have direct and immediate impact to individual and communities and more visible and tangible. While sustainability may be, on the other hand, is more long-term and its impact is not directly visible. I think the other aspect was probably around the measurement and sustainability, primarily from KPIs for API. Like how do you measure the environment footprint of AI is a very complex process. It requires understanding the energy consumption, source of energy, hardware life cycle, KPIs. And most of these, I would say, was still under exploration a few years back. And now with standards like the software carbon intensity from the Green Software Foundation, we at least have a standardized methodology on how can you measure the software carbon emission and go about reducing it. So I see with all these sustainability improvements coming in, we need to look at and ideally the environment.
I think I might have
just
please.
Just to emphasize Navveen's point there, I think the direct impact is certainly a factor that maybe some people just weren't considering some of the environmental costs, and that has kind of created a little bit of a vicious cycle. So the standards that you see around responsible AI, even the regulations that are coming out around responsible AI, the government and regulators are more focused on those direct impacts. So most of them will say things like, well, you need AI to be fair and just and transparent and explainable and accountable and all those things. But very rarely do you see sustainability or environmental responsibility in the standards. And then now in the regulations, it's just now starting to pop into those conversations. So it's a good thing, but it's certainly behind a lot of those other issues.
It's interesting that you mentioned a notion of directness, right? In another sense, the impacts are very direct, particularly in communities where, large data centers are going in. There's contestation over water, there's contestation over energy, right? At another end of the equation, right? Once you're down through the software stack and into the infrastructure, the world, the effects are direct indeed, and yet we're not making the connection somehow. Okay. Speaking of contestation, let's move now over to policy, right? So the policy world is certainly catching on that this is an issue. Again, Elif, maybe I'll start with you. Can you help us understand, particularly for software practitioners out there, what do they need to know about the potential regulations that may or may not be coming down the pike?
Yes, I think one thing to highlight here is that this is something that is increasingly catching attention also in our regulatory horizon scans. So there is the EU that announced their commitment to green transition as well as digital transition. And maybe some of us already heard about this quite famous proposal for the EU AI Act, which has recently received amendments from the European Parliament, which added a much more extensive focus on green goals than the original proposal. Some of these are binding requirements and some are voluntary. I can just give one example of a binding requirement. This is for high-risk AI systems, and it is in the lines of foreseeable and emergent environmental risks shall be identified, assessed, mitigated throughout the life cycle as a part of the risk management system. So it's important to note that this is a draft act and these are only proposed amendments. So it does not mean that this will be in the final and enforceable version of the act. But I think it's important that our audience knows that there is some regulatory movement specifically on this.
Chris or Navveen, did you have anything to add?
Navveen, you're on mute again.
Sorry. So yeah, I think as regulation evolve, right, a proactive approach would be required to continue adhering to best practices. For instance, this includes doing the right thing, right? Let's say building explainable and transparent AI models, embedding sustainability, let's say throughout the AI development and deployment process, and ensuring measures are in place to address privacy and bias concerns. So by doing the right things, practitioners can be better prepared for all this regulatory landscape.
Okay.
And
Please.
I'd add there that it is good to see environmental responsibility and sustainability showing up in standards and regulations. But I think if companies are waiting around for regulation, they are going to have a very, very high environmental cost while they're waiting for that regulation. The EU AI Act, I think, most likely won't be enforceable for another, I'm guessing, about 2 years. So there's a whole lot of environmental cost in between now and then. And what we're finding, so we actually rolled out a global AI, basically responsible AI policy across our 60,000 people around the world. And a lot of it is based on the EU AI Act, at least the anticipated requirements of the AI Act. And what we're finding is that a lot of the requirements are on such a narrow scope of the AI that we might be working with. So as Elif mentioned, a lot of the requirements are very specifically around high-risk use cases, which is good, but high risk doesn't necessarily equate to the ones that to the AI systems that have the largest environmental impact. So if you're only looking at reducing environmental impact or making more efficient the environmental impact of these high-risk AI systems, you're not necessarily going to have the biggest positive impact of that policy. So there's a lot more things that organizations should be doing rather than waiting around for this regulation.
Exactly. I'm going to actually pull a question from our chat here because it's almost related, and I like the question, which is so moving from policy at the sort of the nation state level through to communities and open source. And there's a question here from Roy, who asks, are there significant differences in the environmental impact of open source models versus private models, right? So could folks talk a little bit about what the role of open source and communities might play in actually also changing the greenness or lack thereof of AI?
I'll jump in just quickly. I mean, the reason that we're involved in the Green Software Foundation is because so much of what we do for a living as a company is write software. So very important for us, from the top down, from our CEO on down, that as we are building software for ourselves and with our clients, that we are paying attention to these methodologies, right, to make our software and our technology more environmentally responsible. So that includes what cloud infrastructure we're using and how we work with our clients to understand what is the impact of all their various sort of applications and infrastructures. And then as we write software with them or for them, that we are trying to use the best possible methodologies to reduce that carbon footprint, make that software more carbon aware or environmentally aware. So there's still a lot of work to do, but certainly these are all very important focuses for us.
Thanks, Chris. Since you mentioned some of the nitty-gritty of what you do, I thought we could also talk a little bit about the product lifecycle more generally, and particularly where in that lifecycle, green software and green AI development actually does need to be inserted. So where should we be looking in the life cycle to start to make interventions?
Yeah, I'd like to go.
Navveen?
Yes. So sustainability needs to be embedded throughout the product development lifecycle. For instance, let's say in the design phase, the solution architect optimize energy efficiency and minimal resource usage. And some of the example, let's say, includes serverless technology, event-driven architectures, or using efficient hardware for ML training and infrastructure. Similarly, when it comes to UI designing, you can create artifacts and designs that are optimized and more energy efficient, and basically simplifies the user journey with minimal clicks. Data engineer can look at how can you create, let's say, energy efficient data pipelines, use efficient storage formats like Parquet, or maybe if it's generative AI, how can they store and retrieving vector embeddings effectively. Similarly, for training an AI model, ML engineers can look at achieving performance with energy efficiency. For instance, using techniques like transfer learning, pruning, quantization, knowledge distillation. A lot of techniques are available now, which can help you reduce the resources required for training and deploying an ML model. And finally, from a deployment standpoint, roles like DevOps and infrastructure engineer, right, can look at optimizing the entire MLOps process, like which efficient hardware to use, which low carbon intensity region to deploy based on data governance and sovereignty requirements, and optimizing the model for inference. And finally, we have the QA role, right, who can look at how can you use minimal resources and representative data set, right, to test out the AI models. So I would say the entire product life cycle, right, need to be augmented with AI capability, and each one of the software roles also needs to be augmented and trained, right, to embed energy efficiency and reduce carbon efficiency as part of the AI development lifecycle.
Okay. So there are lots of different places, in other words, and one of the things we know about software developers is that they are also human beings. And you can stick things into the life cycle all you want, and then they're going to act the way they are. And so, Chris, could you help us out here? Could you help us understand a little bit more about, some of the social aspects of how we might want to improve the life cycle?
Yeah, absolutely. Thank you. So, and I think Navveen knows the technical capabilities and methodologies far better than I do. My background and my role is a lot more on the policy side. But I would say, even if you take a step away from the product or project lifecycle for a second and think about the culture of your organization, if you're a startup that has a handful of engineers and data scientists, or if you're a larger company like where Navveen and I both work, there's a cultural aspect to this that I think is often ignored, which is, a lot of times the developers and data scientists are moving very quickly to achieve certain objectives, right? They want to get a product out to market, or they want to get something up and running. They're focused on things like efficiency and accuracy, and then all the other aspects of responsible AI. If they're not thinking about environmental impact, if they don't have incentives around environmental impact, taking the time to think through, are we using a data set or software or infrastructure that is more environmentally responsible? If they don't have the room to have those conversations, or the space to go through that thought process, it's very likely not going to happen. So I would say, however large your organization is, creating that space, creating those conversations, maybe putting some incentives in place, highlighting people that have put together innovative solutions to reduce carbon footprint or environmental footprint. All of those help to create a culture where people are thinking about this and hopefully doing the right thing. And then if you're able to highlight it, it basically alleviates you from having to come up with every possible solution. You're putting the solution in the hands of developers who are very likely going to be very innovative. They're going to be thinking of solutions that they can share with each other. You can highlight them. Again, you're creating that kind of space and room for the conversation, as opposed to trying to dictate, this is the infrastructure to use, these are the software coding methodologies to use, and so forth.
Fantastic. And along those lines, and maybe this is a question for Elif, are there roles that cross-organizational fora, like the one we're in right now, could play in encouraging that creativity and stimulating the right action?
Yes, definitely, Dawn. I think there are newly created roles that we start seeing that is looking at AI sustainability, such as an AI sustainability officer or a digital sustainability officer. But definitely, like we also mentioned as an issue, that disconnect, to also overcome that disconnect, I think we also want to increase the awareness in the community that you also now very nicely put forward. It is not only the awareness about what needs to get done, but it's also the awareness about how can we facilitate and support the teams to get there. This may be through a dedicated officer that will be working with different teams, cross-sectional teams, but this can also be through different means on how to improve collaboration without overburdening, and to think on, like Chris mentioned, further initiatives that can facilitate these dialogues.
Fantastic. Does anybody have anything to add before we go on and get into the technical weeds a little bit? Okay, just thought I'd keep it open. Okay, now let's talk technology a little bit more specifically. So Navveen certainly mentioned a couple of approaches. One of the things that I certainly see happening is a great emphasis currently on particularly efficiency methods, right? Quantization. There's a long laundry list of favorites that folks have. I also see in other communities a great deal of skepticism about the role of efficiency, because one of the things that we know is that when you make something more efficient, people tend to consume more of that thing, and you can actually sort of backfire the situation entirely. There's also an interesting question in the chat here about sustainability metrics, right? Queries per watt and so forth, that might be a different approach entirely to containing this problem. So my question to the panelists, and this is to everybody, is what specific techniques do you think are most promising or underappreciated that you would like people to know about in tackling this problem? You got to help me out here.
I'm looking at Navveen.
Yeah. So
Navveen, maybe we'll start with you as our technical guru.
So yeah, I think we need to look at both energy efficiency and decarbonization for an AI process. So just to talk about the entire life cycle process, right? We have to look at this holistically. For instance, let's say you start with data acquisition for your ML model. We can explore options like, let's say, small data set, pre-processed data, and let's say avoiding deduplication logic, right, at the start of the data acquisition process itself. Then you go about choosing frameworks that are more energy efficient based on task specific performance. For instance, there are research which shows that, let's say, TensorFlow is good for recommender system, and maybe PyTorch for NLP task. So you can choose one of the two frameworks and identifying which one is more energy efficient. Similarly, for a data storage perspective, because you ultimately use some kind of data storage to store your models, you opt for energy efficient formats, which, let's say, facilitate efficient data retrieval. Like things like generative AI, right, which also talks about how do you store vector embeddings. So there are a lot of specialized energy efficient data stores that can be used to effectively retrieve embeddings and put generalization or recommendation on top of it. Also, you have to understand the trade-offs between accuracy and energy efficiency, right? It's not just what I've also seen is you will see a lot of LLM models, right, being released with marginal accuracy, but still it has a significant carbon impact. So you need to be aware of the trade-offs when you between accuracy and where you want to stop accuracy from an energy efficient point of view. When it comes to model, I mean, you can make a efficient model using techniques like pruning, in which the less important connection between new data are removed. New techniques like knowledge distillation, where you basically work with small learned models, and things like quantization, where you round off the weights. So all these techniques are now available, which can help you create optimized model. And finally, you have the underlying hardware. So which hardware to choose from an energy efficiency point of view. So overall, you can make the entire process also carbon aware to shift workloads or run on regions, right, where there is low carbon intensity. So collectively, if you try to address all of these problems and embed energy efficiency in your entire AI life cycle process, it can be more efficient, energy efficient, as well at the same time have a significant carbon reduction.
Thanks, Navveen. Elif, do you have anything to add here?
Yes, I can only add from more of a governance angle, maybe. So there are some unique examples that we hear about, but there's also some, for example, regulatory developments. Again, these are proposed laws. This one is from Germany, where they are planning on maybe passing a law that might be putting up some requirements on the minimum PUE for data centers as well as HPCs. That should be around 1.5 by 2027 and 1.3 by 2020. So why would that be maybe relevant? Because if we are seeing, again, more movements in policy and regulatory space, we might be getting more support then for these teams that are in charge of finding these more creative methods through their management as well. And in that, I think it's also important to know that there are some companies like Hugging Face, they did vote more towards transparency regarding their algorithms. And there's a famous one called Bloom, where they really wanted to share then also in an open source way with the developers as well, the methodologies they used on trying to make it more efficient. So maybe this kind of community support is good. And one unique example that was reported in The Economist recently was from Finland. And this is regarding among the most powerful supercomputers in the world. One of them is located in Finland and was promoted to have negative emissions because it was powered by hydroelectricity, and they were able to use the waste heat to heat buildings in a nearby town. So I am not an engineer, and to me it sounded like a very nice fairy tale, because I also learned that it was called Lumi, which meant snow. So I will leave the realistic assessment of applicability or inspiration for further applications to the audience members.
Yeah, yeah, I absolutely love that example. There's a question here in the chat about measuring carbon impact while shifting regions. And if you don't mind my sort of pretending I'm a panelist for a little bit, because I can't resist, it's a question that's so dear to my heart. One of the things that I've been looking at in my own work is the kind of the social aspects of what it takes to actually time shift or space shift workloads. I personally see engineers wrestling with, okay, where is the data versus where is the green, where do I get access to green compute, right? So there are some very real trade-offs there. The other trade-off that I've been finding that I hope might be interesting to people is the trade-off in time shifting, right? There's times when you can absolutely wait 6 hours, 10 hours, multiple days. If you're trying to get something out the door to meet a deliverable, you can't do that, right? So the time shifting and the space shifting are very much shaped by the social conditions that people are working under. So I'm a fan of the carbon aware stuff, but we got to be realistic about how that's actually going to work in practice.
Yeah. I just wanted to add on that is, see, a lot of, you can do time shifting and region shifting, right? Let's say for non-production environments also. So I understand production would have a data sovereignty requirements, and you need to abide by the SLAs. But if we structure our approach around development and non-production, then definitely we could have the flexibility, right, to shift, choose the right region also, because pre-production will not use, let's say, customer data, and also leverage, right, the time to run your build your applications, right? Till it goes to production.
Yeah, exactly. It's all about where your stuff actually is, as it turns out. Okay. Two more questions, and then we'll jump in much more deeply to the chat questions. But the next to last one has to do with mistakes. And so, right, both these fields, both sustainability and responsible AI, have a track record, right? On the responsible AI side, one of the tendencies that at least I see happening is to make some very difficult questions into tick box exercises, right? If we're not careful, things can sort of descend into that kind of social logic. On the other hand, we know from some pretty robust sociological, anthropological studies that, and I'm sure others, that carbon accounting, for example, has a lot of issues, right? You can play scoping tricks until you're blue in the face and come up with all sorts of interesting claims. So my question, and maybe we'll start with Chris here, is on either side of the equation, which risk, tendency, problem, mistake would you like to see us leave behind as we turn to greening AI?
Yeah, I'll do two really quickly. I mentioned the other one briefly, the first one briefly earlier, which is this idea that organizations are kind of sitting around waiting for standards and especially for regulations. I would say every company that I see, any large company, any company that we work with, has some kind of sustainability metrics, some kind of sustainability goals, objectives. Maybe they're corporate social responsibility, maybe they're called something else, but some kind of goals around environmental responsibility. If that's true, I'd like to see how they are instilling those goals into their product lifecycle. And that includes AI as well as everything else we're working on. So I would say don't worry so much about waiting for the regulation and how are they going to require measurement and reduction and things like that. Get started now, create that culture and create those incentives to do the right thing. But I would say maybe even the bigger challenge, the bigger mistake that's happening right now, all of these standards and regulations, most of the conversation around ethical AI or responsible AI is talking about these harms as risks, right? And Elif made a great point earlier. The EU AI Act talks about these high risk systems, and you should be able to identify and measure and articulate your environmental risks. These aren't risks, right? These are known costs. The labor costs, the environmental costs, the social and geopolitical costs are known trade-offs. They're known harms. They're known cost of the AI work that we're doing. So if you're thinking about measuring these as risks, like likelihood and impact, as you would in the traditional kind of risk management framework, you're missing the boat on the real trade-offs. So as I mentioned earlier, when you're doing experimentation, when you're running these large models, when you're doing large kind of training exercises, you should be thinking about these things in terms of costs, not risks. So that would be the second mistake that I see happening a lot with the clients and organizations that we work with.
Okay. Very, very last question before we go full Q&A free for all, which is, given all that we've just talked about, all the constraints, all the opportunities, and I'm going to go around the virtual room again. Do you think there is such thing as green AI? And if so, how would you define it? Or conversely, if you're a little bit more skeptical, would you go so far as to say that AI might be a threat to net zero for companies who do have net zero goals, or conversely, an opportunity if you're an optimist? So I'm going to go around the room again. I'll start with Elif.
Let me take on the optimistic role then.
Okay.
So I will say it a bit like this. So I think it might slowly get more central stage in the discussions of the management teams. And like Chris puts, this might or might not be because the policymakers are paying more attention to it. And then hopefully this can lead to more support for the solution builders. And here it's important, again, Don, you really highlighted it very nicely. It should not be that the company is just dictating these goals to the developers. It has to come with enough support so that they can achieve these goals. And I will say that if we manage to follow through and take all of these right steps, hopefully, yes, we can have greener AI.
Thanks. Navveen, what do you reckon?
Yeah. So green AI is basically embedding energy efficiency and reducing carbon emission as integral to your overall AI development and deployment process. And some of these aspects we covered as part of the discussion. So it's all about making environmental conscious decisions at every stage, let's say from data acquisition to processing to model training and monitoring. And my view is in the next maybe 2 to 5 years kind of horizon, green AI should be synonym with AI, where energy efficiency, carbon emission reductions, responsible utilizations are integral part of AI projects right from its inception. We should have the right tools to measure, monitor, and optimize. And AI, when we talk about AI, it would be green AI. By definition, so we don't need to talk about green AI. It's like a security, right? So like a security for an application, right? You don't not talk about application needs to be secure. Now we assume that application is secure by default. And my view is if AI emissions are not handled carefully, especially things like generative AI, large language models, and maybe in future, right, things like metaverse will also use a lot of these combined capabilities. AI can make it harder for companies to reach their goals for net zero emission, because training and running AI models requires a lot of energy. But if the companies embed green AI principles, it can help lower the environment footprint, and this also encourage creation of better, more efficient AI technologies, making AI more green and sustainable.
Thanks, Navveen. And we'll give the final word to Chris.
Well, I will say I might take the more pessimistic perspective, but I will use Elif's comment. I think this idea of greener AI is right on. I think this is an extremely challenging thing to do. And like I said, I'm a bit pessimistic that we can do something called green AI with any kind of consistency. But I do think there's a whole lot of work we can do to make things more responsible. And I think about it like you pick a large city somewhere in the world and say that they're about to roll out a fleet of 1 million cars on the road. Well, you can make those cars more environmentally responsible, but you know for sure there is going to be some kind of environmental impact in all the hardware, all the operating costs, the pollution, and so forth. Well, same thing with AI. If we all of a sudden start using a whole lot more AI, we know there will be an environmental cost to that. So we should be very thoughtful, first of all, as to why we are using AI in the first place. What are we trying to accomplish with it? What kind of value are we getting from these projects? And as Navveen mentioned, there's all kinds of work that we should be doing to make sure that trade-off is as environmentally responsible as possible. Reducing those environmental impacts as much as possible, but being thoughtful about why are we using AI in the first place. So greener AI for sure. Green AI, I'm a bit skeptical.
It sounds like we have a lot of opinions also in the chat. That is an excellent outcome indeed. Exactly what we were going for. Okay, that's all of the questions we have pre-prepared. I'm going to now turn to some of the questions in the chat. So lots of commentary about greener AI. Is it possible at all? What do we need from a, should we just be straight up and be transparent about what we can't do? Please keep them going. I think it's a wonderful debate to have. I'm going to actually pick up this question that comes from Mohua, which I believe, if I understand my geography right, might be in New Zealand. I hope I've got it. And they ask about energy sources and where, we can, green AI at a software level, but we do have to understand where the energy actually comes from. And so I was wondering so the we sounds good, and that seems true and right. At a developer level, or maybe, somewhere between, maybe at an infrastructure, builder level, how can a developer even know where their energy is coming from? How much choice do they actually have? Maybe Navveen, I'll throw this to you as somebody closest to lines of code.
Sure. So I would say a lot of cloud providers now provide you, especially, which regions are more greener, right? So you can choose a clean-free region, like Google publishes which region takes more carbon-free energy. So using that, you could deploy your applications on region which has clean energy. Secondly, now there are also APIs available. For instance, whether it's through Watt Time or electricity map, which gives you based on region, geography, right? You can just call an API and tell you can get the carbon intensity. So now you have providers as well as APIs available, which you can pick and choose and determine, right? Where do you want to run your application, whether you're doing region shifting or whether you're doing time shifting.
Any other comment on that before I pick another one? Okay. There's also a kind of a more of an organizational style question here, which is somebody who is a sustainability engineer in an open cloud provider asks, how can we promote sustainable IT initiatives beyond business-driven motivations, right? So the way, sometimes folks are motivated by, what looks good on a balance sheet. Other folks are motivated differently. So talk about those two things and whether you see non-business motivations actually featuring more.
I mean, I'll jump in real quick. I think they can be business motivations without necessarily being financial. I think, obviously cost reduction is going to be a big thing. If you can improve performance and or reduce costs, those are going to be very favorable for a lot of the businesses that you work with. But as I mentioned earlier, almost every business that I talk to, every executive that I talk to, their organization has some kind of sustainability targets, goals, objectives, voluntary reporting. In some cases, it's a required reporting. If you can connect the services that you're providing, the environmental benefits that you're providing to those goals, they're not necessarily going to be bottom line benefits. It's not reducing cost or improving performance, but you are showing that the work that you're doing and the work that they're doing with you is going to help support them reaching those target metrics. That's been resonating extremely well with the people that I've been talking with.
That's super helpful.
Maybe I can add to that, and I can also formulate it as a question, because one idea of looking at it is, if there was some standards that the community could come up with when it comes to calculating what is, for example, the emission cost of this model versus that model. And if we could also encourage then the developers or the teams to make this information public, right? That was a bit the example from Hugging Face, that they wanted to vote for transparency. So if we said now that the companies would be using these algorithms, but they would be also transparent on its energy efficiency, would this change customer behavior? Would this support certain missions better of certain companies? So is this different than a business case? So that's the part that I think, formulate into a question, but that's how I think I would approach a question like this.
That's fascinating. Yeah. Sorry, I'm thinking about what you just said. I'm also like, wow, yeah, no, that's good. It's pretty much spot on. We're going to go over now to a more technical issue. And John Clark has actually asked a really, it's more of a statement, but it would be great to have some comment on this statement, because it's just fascinating. So he says, data storage and AI will function as distinct components in new AI architecture, with data storage handling the storage and retrieval of information, while AI processes and analysis of this data to derive insights, right? Where he's going here is new designs, new optimizations might be required beyond what we have today, presumably. So I hear that question as, where are the opportunities for innovation, right? Where do our standard methods not work, and where do we need, where are the most opportunities to really think harder from a more of a systems architecture level, is how I interpreted this. So any comment on that?
Yeah, so if you look at the data lifecycle, right, for AI as well as generative AI, right, that needs to be looked at it holistically. So there is definitely a lot of innovation that needs to happen. Right from, let's say, how do you acquire the data in the first place? How do you make it more energy efficient? Maybe how do you do carbon away data acquisition? Then how do you store the data, particularly with generative AI models, corporate data, things like vector embeddings? How do you store in an efficient way? How do you retrieve it? Similarly, how do you cache the data or make data available, right, to, let's say, billions of users if it's used by generative AI? Prompts, I would say, right, are things that also the response. I mean, how do you look at prompts collectively? How do you look at the storage of prompts? How do you look at user sessions? All I think provides ample opportunities and innovation in this space, right, to look at handling data efficiently, including, let's say, archival data, backups. All will end up keep on piling up, right? So backups also needs to be taken into consideration. And just to give you a stats, it says that's around 60 to 80% of data that is used in any organization is dark data, which is not used for any meaningful insights. So enterprises or still sitting on a lot of data which is not being used, and with especially with new techniques like generative AI requires more data training and everything, right? This will keep on piling up. So definitely, I would say the next innovation I think needs to be around how do you manage data effectively, efficiently, more from a sustainability point of view.
Exactly. Very last question, I hope. I'm going to combine a couple of these in the chat, and I'd like to talk about measurement and quantification, right? So there are a couple of questions that, to my mind, kind of amount to how much of this is actually quantifiable at the end of the day. How much measurement do we need? What kind of measurement? I'll even throw in there, what are some challenges that you're seeing in getting realistic and higher quality measurement going?
See, from a measurement point of view, so I think from a measurement point of view, I like to talk about the software carbon intensity specification, which provides you a standardized approach, right? How do you measure the carbon emission for any application, including artificial intelligence? And there are also a lot of use cases that Foundation has released. Now, can you measure, let's say, a large language model, what it takes to measure a large language model from an SCI point of view? And the good point about SCI is the specification talks about reduction. So it gives a developer, I would say, a means to act, not just report carbon, but how can you reduce the carbon, right? By giving you an SCI score. So once you get an SCI score, you can go about reducing it, let's say by writing, let's say, energy efficient architecture, which I talked about with various model techniques. We have published a lot of green AI patterns, which can be used for lowering the carbon emission and making things more energy efficient. You can use optimized hardware, changing hardwares which are more energy efficient, or the third can be carbon aware, which I talked about. So I would say the tools are there. I would say tools needs to be more streamlined. Tools needs to be available to each ML developer. We're not there yet, but we have, I would say, that's right standards and early set of tools, right, which can help you to measure and report carbon emissions.
Yeah, I'll also just jump in and add, because I can, that there's some really great social scientific work from Ann Pasek, who shows, and I'll put a link when we're done in the chat if I can, that measurement has everything to do with what you're trying to achieve, right? And getting once and for all, accuracy is not necessarily the most useful thing all the time. And measurements that are actually fit for purpose in a specific social context, it seems to have a lot more promise. So I would advocate for that to the extent that I can.
I would just add a quick plug. I mean, one of the things that we measure is how many of our developers have gone through training on Green Software Foundation techniques. Right? There's some accuracy there. We don't necessarily know what the impact is of that training right away, but we can measure progress by how many people understand some of these techniques, and you can do the same for a lot of the things that Navveen has been talking about.
Yeah, exactly. We are at the top of the hour, or the top of the half hour, depending on which part of the world you're in. So I am going to thank our guests and thank you all for some tremendous insights. I certainly got a lot out of it. I hope people in the audience did as well. We covered a lot of ground today, and some optimism and some skepticism along the way, which I think is always the perfect balance. So with that, I'm going to kick it over to Namrata for any final thoughts.
Hello.
I am.
Can everyone hear me?
Yes.
Okay. Oh, there we go. Well, thank you everyone for joining. And thank you to all the panelists. Thank you, Dawn, for such a wonderful conversation. I think everybody has walked away learning a little something. I wanted to just close out and inform everybody that has joined us of the various ways they can stay engaged with the foundation. We've got local meetups all over the world where green software practitioners come together. We've got a training that we encourage everyone to take, especially in anticipation of decarbonized software, which is on November 16th, to get the language and foundational knowledge, to really be active participants in the green software movement. And we are also on social media. We have GSF discussions and our podcast, Environment Variables, where we really dive into some of these nitty-gritty topics and have conversations with leaders across industry. Not to mention our weekly newsletter, which goes out every Friday, where we share the latest resources, tools, perspectives, developments in our open source projects. So these are all the different ways you can sort of stay engaged and keep a beat on the pulse. I also wanted to just take this opportunity and let you know what's coming up next. Again, Decarbonized Software is going to take place on November 16th. Registration is still open, and we encourage everyone that's interested in the topic of responsible AI and digital sustainability to participate. We are also going to have a fireside chat, really, taking the conversation and questions from today to get a little deeper, get a little bit more technical. So if this is your domain, you definitely want to be there. That's all from me. Thank you so much. Dawn, I'll pass it back to you.
Gosh, well, yeah, I'm just going to quickly say thanks again, and let's wrap up. And many of us are about to start our workday.
Thank you all.
Yes. Thank you.
Thank you.
Thank you all for joining.
Thanks,
and
everyone.
thank you
Thank
to
you.
all the panelists.
Take care.
Bye, everyone.